Okay, so let's draw ourselves a foot, okay? 1, 2, 3, 4, 5 toes. Now we've got landmarks, and that was L1, haven't we? And that was L2, 3, 4, 5, and the little toe was L6. So let's suggest that what we want to do is measure the distance and know the distance L6 to L1, which is that dimension. Now we know that this is basically a graph, okay? And that's the y-axis and the x-axis. And for each of these values, we have an x and a y value, and we have an x and a y value for that. Of course, there, right? So what we can do is we can use that. So if we come down here, that's L1x, come this way, and that's L1y. So we'll do that one to 6. So it comes across as a straight line. So that's L1, so it's L6. Let's try and write that properly. And that's y, okay, and it comes down here. And it's L6x, okay. So now that's really very useful for us. We want that distance, but actually what we've got is a right angle. Okay, so A and B, we know that basically x squared plus y squared equals 8 squared. That's just Pythagoras. So that's a squared, putting these in, b squared gives us the distance that we want there. Okay, so we know that. So to work that out, to work A out, A has got to be L6x minus L1x. B has got to be basically L6y minus L1y. And we have everything that we need to work out that distance by just using the coordinate systems that we have. Okay, so what I've done for you is I've gone through all of this data, and I've done it with the landmarks and 5 to 20 and all the landmarks like this, and I've done it for all the feet for you. Okay, now what you can see, and you need to be careful of it, is that these feet change sizes, and so we need to remember that this is an image and that the true distances may not work. So what do? Well, we export as a CVS file, which is a comma separated file. We export that, okay? So when we export that, we end up with something that looks like this, which is fairly hideous, to be honest. And what we've got is, you know, that's 12 landmarks. Initially I did it, let's get one with 14 on it. There we go. I wasn't scaling to start with. And you've got all the landmarks, and that format is really, really not usable. And you can painstakingly move and organize the data. But as with most research purposes, I have a little piece of algorithm that I can use. Now, you don't need to worry about this, but it allows me to do the whole data. So if you were to measure lots of data, then I would read this and convert it for you. And I read in the file, and it manipulates it, pops it out like that. And then when we're done, it's going to look like this. Okay, so what we've done is now we've got the XY, XY, XY all the way across, and that makes life a lot easier for us in order to manipulate this. Okay, we've got figures down here. Now you can also see that I didn't do the scaling for everyone, or I messed it up to start with. Originally I was going to 0 to 20 and then 5 to 20. So we need to think about the fact that I messed that up. So I've copied all of that and I've put it onto a new sheet. Okay, and all we will want to do here is work out the total length of the foot. So that's landmark L1 to L2, heel to the big toe, right? So I've got my coordinates in here, and this is where I've done my scaling. So the first thing to remember is that this is Pythagoras, okay? So to get the distance, L1 to L2, it's the square root of the difference between basically the X and the X, and then here the Y and the Y, okay? That's all that that's doing. So I've done that. Now, as I said before, that is a pixel distance. It isn't a real distance. So we need to know what that equates to. Now, that's why I was putting landmarks 13 and 14 on 5 and 20. So there should be exactly 15 apart. So basically just Y should be basically that minus that is the distance that they're apart, and 11.84 pixels should correspond to my 150 millimeters. So I've gone down to the bottom and I've done an average, okay, an average of all those measurements, so averaging the scaling. And then of course I can then go K3, or that column, and basically the dollar signs mean it's fixed to that cell, the scaling cell, and I've scaled them, and these are my true millimeter scales, so we could actually say that these are now millimeters, and that's the distance, and that's the size of all of those feet. Now I've had to delete the odd file where I've messed up the landmarks. You could go back and correct them and add them in, but effectively that's what we need. Now, if you need to understand the difference here, this Pythagoras basically, I'll cover that in a separate video in a moment.